Okay, guys, so you learned about phosphoglycerides. These phosphoglycerides are also known as phospholipids. Okay, so different types of phospholipids you have learned. And if you see the structure of phosphoglyceride, the first OH group of glycerol is esterified to fatty acid molecule, and the second OH is also esterified to the fatty acid molecule, and the third OH group is esterified to the phosphoric acid molecule. So these are like a long chain hydrophobic. Fatty acids are like a long chain hydrophobic chains. Okay, so these two can be represented like a lines, and this one is a head group. It is a these two are hydrophobic and this is hydrophilic. Phosphate group is hydrophilic because of the negative charge. So these phospholipids can be represented like this here, the head group and the tail. Okay, so the head round shape, which is head group, which is phosphoric acid group, and the two tails are corresponded to the fatty acid molecule. Okay, so these phospholipids, when they are added to water, they arrange themselves into bilayers and micelles. This is because the phospholipids this is because the phospholipids are hydrophobic and hydrophilic in nature. So they are both hydrophilic and hydrophobic. The fatty acids are hydrophobic in nature, and the phosphoric acid, the phosphate group, is hydrophilic in nature. So the fatty acids which are hydrophobic in nature, uh, which arrange themselves such a way that they are away from the water molecule, so they are inside. This is the if you consider this is the aqueous media, the phosphate groups are towards the aqueous media, and the hydrophobic chains, that is fatty acids, are away from the aqueous media, so they form a bilayer. So this is known as a bilayer, and which is the backbone for the cell membrane. Okay, and also they form a micellar like structure. So in this, the fatty acids are arranged inside, that is away from the aqueous media, and the phosphate groups are towards the aqueous media. This is the aqueous media. So because the fatty acid groups are hydrophobic in nature, they keep themselves away from the aqueous media or water. Hydrophobic, they hate water. Hydrophilic, they love water. So these phosphate groups are towards the water, and hydrophobic fatty acids are away from the water. So the molecules which consist of both hydrophilic groups and hydrophobic groups are known as amphipathic molecules. The molecules which contains both hydrophilic and hydrophobic groups are known as amphipathic molecules. Okay, so phospholipids, when they are added to water, they generally form a bilayer or a micellar like structure. Micellae or micelle, however you want, you can pronounce. So next, these phosphoglycerides are more soluble in water than the triacylglycerols. Because of the phosphate group, they are more soluble in water than the triacylglycerols, forming solutions from which they can be precipitated with a cold acetone. Thus, you can leave it. Next, coming to biological importance of phosphoglycerides. These phosphoglycerides are important components of the membrane system of all the cells. So, because they are the backbone for the cell membrane. So the lipid bilayer which formed by the phosphoglycerides constitutes the backbone of the cell membrane and organelle membrane, and determines their permeability characters to a greater extent. So you have heard the cell membrane is semi-permeable in nature. That means it is off permeable. Only certain molecules are allowed inside or outside. So that is due to the phospholipid bilayer. The semi-permeable nature of the cell membrane is mainly due to the phospholipid bilayer present in the cell membrane. Then this another important for phospholipids is these phosphoglycerides are involved in the transport of other lipids in the bloodstream. So the phospholipids, which are more soluble in water compared to triacylglycerols, they helps in transportation of other lipids through the bloodstream because they are insoluble in water. The lipids are insoluble in water. Phospholipids helps in transporting the other lipids in the bloodstream. Another important property of phosphoglycerides is that they function as a surfactants. surfactants like soaps. So they lower the surface tension of the solution. Hence, they are used in large amounts in the food industry as emulsifying agents. So one of the property biological importance of phosphoglyceride is the phosphoglycerides or the phosphoglycerides are backbone for the cell membrane. The semi-permeable nature of the cell membrane is mainly due to the presence of phospholipid bilayer, and they help in transportation of other lipids in the bloodstream, and also they act as a surfactants. So they are mainly used as a emulsifying agents in the food industry. So this is about biological importance of the phosphoglycerides. So next, coming to the structure of cell membrane, this is one of the well-known structure of cell membrane, fluid mosaic model. I think you have studied in zoology already. So this fluid mosaic model was proposed by S.J. Singer and J.L. Nicholson. So this model is also known as Singer and Nicholson model of the cell membrane. So composition of the cell membrane, so which consists of phospholipids and proteins in the ratio of 1:1, and it also contains 2 to 10% of the carbohydrates and some cholesterol molecules. So the cell membrane has a thickness of 8 to 10 nanometer. Okay. So next, coming to the structure, so this is the phospholipid bilayer, phospholipid molecules, and this is the phospholipid molecule, so which forms a bilayer, phospholipid bilayer. So in that, the head grooves are towards the aqueous media and the tail grooves are away from the aqueous media. And some here, the phospholipid consists of hydrophilic and the hydrophobic tiles. They are arranged in a bilayer. The hydrophobic heads are directed outwards in contact with the water, and the hydrophobic or arrange themselves away from the water, directed inwards, out of contact with the water. Next, the hydrophobic tiles gives a fluid nature of the cell membrane. So this, because of the movement of these molecules, that gives fluidity to the cell membrane. So because of this, the cell membrane has semi-permeable nature. Okay, so the protein molecules are either completely embedded or partially embedded in the lipid bilayer. So